Our topic is now buoyancy, and we're going to try to do a couple buoyancy questions where we basically determine the buoyancy force, the gravity force that would be counteracting that buoyancy force, and then see what that information can tell us. So in this question, this man is pulling a boot out of the water because he's been fishing and he caught himself a boot. And it takes 200 newtons to pull the boot through the water. So while he's lifting it out of the water. But once he's on the surface, it takes more force. It takes a whole 320 newtons. Now that's because once he's out of the water, there's only the force of gravity. There is no buoyancy force anymore, right? We only have the force of gravity. So that means that if I want to figure out the buoyancy force, I just have to think about what's happening. So when I'm in the water, then the applied force while I'm in the water is 200 newtons. Now remember, when it's in the water, I have gravity pulling down, but buoyancy is also helping me out a little, right? So the buoyancy force would be helping me, that's supposed to be a B, would be helping me with the entire thing. But once it's out of the water, then it costs me a whole 320 newtons. And in that case, I have gravity pulling down on it, right? I also have my applied force in both cases. I'm applying my force as well, right? And then in this case, my applied force would be equal to my gravity force. So what does that mean? Well, that means if I want to find my buoyancy force, it's pretty straightforward. All I really have to do is think about the difference in the forces. So if I'm thinking about those forces, in this case, the buoyancy force is reducing the amount of applied force I need. And in this case, it's showing me the total applied force that I need without a buoyancy force. So that means my buoyancy force would be equal to just taking my one out of the water, 320 newtons, subtracting the force I need while it's in the water, and it shows me how much the buoyancy is helping me. So the buoyancy force will just be 120 newtons. The difference between me lifting it with the help of the buoyancy force versus without the help of the buoyancy force. Now there's other things I can do as well. The second question, we're going to determine if this ball sinks or floats. So we're going to look at mathematical proof to prove that it sinks or it floats. And basically to do this, I have to compare my buoyancy force to my gravity force. As long as my buoyancy force is greater than my gravity force, then that object will float. If my gravity force is bigger than my buoyancy force, it will sink. That's why in this question here, the boot sinks because the buoyancy is only 120, but gravity is 320. That's why the boot sank to the bottom of the water in the first place. In this case, we're going to find out if this ball sinks or floats. So we're basically going to calculate both forces and then go from there. So I'm going to start with thinking about my buoyancy force, because the force of buoyancy, remember we got this equation where we look at the mass of the liquid times gravity. Now remember, my liquid, it says it's 400 milliliters, which will be the same as 400 grams. But remember, I want that in kilograms because I'm going to put it in my force equation. We always have to work with kilograms in order to get newtons. So I can just find the buoyancy force by finding my 0.4 times my 9.8, and that'll give me the buoyancy force. Because remember, we're finding the mass of the water, or the force of gravity on the water that's displaced, because it'll displace the water it needs for that buoyancy force. So that gives me a buoyancy force of 3.92. Then I'm going to compare this to the gravity force. How much is gravity pulling it down? Because as long as my gravity force is less than buoyancy, it floats. If gravity is more than buoyancy, it sinks. Well, we know how to do this already. We take the mass of the object, already in kilograms in the question, times 9.8, and I would find I have a gravity force of 2.94 newtons. Now you'll notice my gravity is less than my buoyancy, which means in this case, it floats, right? I can say quite easily that it floats. So the ball floats since the gravity force, 2.94 newtons, is less than buoyancy of 3.92 newtons. It's just a comparison. You can always tell if something